Today we are going to talk about chapter 9. It's about energy in general. Energy, it's type of what's the meaning of energy or where we can see energy. I cannot measure energy directly. I can measure energy change. Okay? So energy change we can measure it in chemical reactions and we can see that energy can be released or absorbed. Okay, so I'm going to classify any chemical reactions into two types. Type number one, exothermic reaction. Type number two, it's endothermic reaction. Exo related to exit and endo related to in, come in. I will start with exothermic reaction. What's the meaning of exothermic reaction? It's a reaction that releases or gives out energy to the surrounding. So, if we put some reactants in a test tube and we feel the temperature of that test tube after a while, we can see what a heat that a heat rise, okay, a heat rise or a temperature rise. That's from what? Releasing energy. So exothermic reaction, it's a reaction that gives out energy or release energy to the surrounding. The surrounding, it could be the solution mixture, the air, any liquid. It's not the chemical system, it's the surrounding where the chemical system takes place. Okay, so in general, a chemical reaction, its component is reactant. I will start with reactant. They will react with each other to give me what? The product. Exothermic reaction, in the same time, it will give me what? Energy as a product. Okay, this is the equation. The equation that shows the energy in the side of product, we can say that this type of chemical reaction is exothermic chemical reaction. Okay, also we can represent the chemical reaction in a diagram. That diagram is called energy level diagram. In that diagram, on the x-axis, I will put what? The reaction pathway. Okay, we can see here that on the x-axis we have reaction pathway. What's the reaction pathway? Any reaction pathway starts with reactant and ends up with what? Product. This is a pathway. On the y-axis I will put what? The energy. The energy here is measured by the unit kilojoule or joule. Okay, we can measure energy by kilojoule or joule. Okay. In order to say we have what? An exothermic reaction, I can see that energy level diagram, it will be represented in that way. It means that I will start with reactant at an energy level, specific energy level. After they combine or they react with each other, they will lose energy in order to give products. The energy will be released to my surrounding. So I can see that products, they will have less amount of energy if we compare it with reactant. Why? Because the amount of energy that was inside the reactant, it was released to the surrounding in order to make the products. So going down from the reactant to product, it means the reaction is exothermic reaction. Exothermic reaction. Okay. So again, the product energy, amount of energy is less than the reactant amount of energy. Okay, it has less energy amount than reactants. Examples for some exothermic chemical reactions: combustion. If we combust something, energy will be released to the surrounding. It means that combustion is an exothermic reaction. Neutralization, it's a type of chemical reaction between acid and base or acid and alkali. And here I have mentioned HCl, hydrochloric acid, with lime. What's lime? It's what? It's calcium oxide. You have to memorize that chemical formula for lime. When I say lime, it's always what? It's always calcium oxide. This calcium oxide, it's considered as what? As an alkali or a basic oxide. So it's alkali with acid. It's a type of neutralization, and neutralization reaction is exothermic reaction. It means it will release energy, or it will give out energy to the surrounding. Also, respiration, you took it in the biology. Yeah, respiration, in that process, our body cells will what? They will produce energy by breaking down the glucose molecules. Okay, you have to know what's the equation for respiration. Okay, I will break down glucose molecules in order to get some energy to have as a fuel to do biological process in our body cells. Okay, the next type of chemical reaction, according to energy change, it's called endothermic reaction. Endothermic reaction, according to this part, the first part, it's N. So the energy will be taken or will be absorbed. So reaction that takes an energy from the surrounding, it's an endothermic reaction, representing or showing that chemical reaction on what? On energy level diagram, reactant absorb energy in order to give the product. It means I will see that product energy level is more than reactant. In what type of chemical reactions? In endothermic chemical reaction. Okay, so you have to know carefully what is the correct diagram for exo and endo. Okay, in exothermic reaction we have downward energy level diagram, and endothermic reaction we have upward, because reactant will absorb energy, will take an energy in order to give products. Okay, examples for that type of chemical reactions: photosynthesis. Plants in general will absorb carbon dioxide plus H2O in the presence of what? In the presence of sunlight as energy in order to make C6H12O6, glucose, and what? Oxygen. Also, we have to know that type of chemical reaction, it's thermal decomposition. What's the meaning of that? Decomposition, it's breaking down. So I'm going to break down chemical component using what? Energy or heating. So my example here is calcium carbonate. So you have to know, any carbonate you are going to heat it, it will be thermally decomposed into what? Calcium oxide, اللي هي, it means the metal oxide, and what? Carbon dioxide. This is fixed product. So all the time, any metal carbonate by heating, it will give me what? Metal oxide and carbon dioxide. Also, we can mention citric acid with sodium hydrogen carbonate. Sodium hydrogen carbonate, that type of chemical reaction is endothermic reaction, and this reaction, it happens in sherbet. You put it on your tongue and you can feel that your tongue is cooled, because the sherbet is composed from citric acid and sodium hydrogen carbonate. The reaction between them is endothermic reaction. So I'm going to absorb energy from the surrounding, from my mouth, so I can feel that my tongue is cooled now. Okay, that's it for today. Hope you are enjoying the videos and get the full benefit of them, and I'm waiting your questions for unclear points. Thank you. Bye bye.